Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2012 Dodge Charger. This vehicle is unfixable. This vehicle has been trying to be repaired for a misfire for over a year now. So the first thing I want to do is I want to get a scan tool, and I want to put a scan tool on the car and just gather some basic data so we can make some diagnostic decisions. So let's go ahead and get the scan tool in this vehicle. Okay, so we went ahead and we got the scan tool up on this Dodge. Let's take a look at it. So right here on bank 1, I'm having a control problem. It's on the RIT side. I also have fuel trim issues. The top fuel trim is long term. The bottom ones are total trim. Now, these are really close together because the bank to bank trims are the same. So bank to bank, whatever's wrong, the whole engine has the same problem and isn't on one bank, or this, I would have a trim error right here. Time to temperature is good, the engine vacuum is good, the charging voltage is good. Now I have a code for 1, and I have monitors that haven't been run, and there's 4. Now obviously the shop that I'm working on this has cleared the codes. Guys, don't clear the codes until the car's fixed. I can feel this car shake right now. It is missing right now. Well, if it's missing, you haven't fixed the car, so maybe we don't clear the codes and I'll have more data. And I'll show you here in a second, we're in mode 6, we've lost a lot of data, and at least we reset a code, and probably that's because the car's misfiring, and it's misfiring pretty bad. I can feel it. So let's go to the DTCs. It says we have a cylinder 1 detected, and this code set under 37% load, and my fuel trims are light on it. We're 10% or so. So not a lot of fuel trim. It's 14% on long, but it's -4, so that's about 10%. So roughly we do have some fuel control issues at a light load is where it's setting. So okay, I'm okay with that. So now I want to go ahead and I want to look at the mode 6 data. So we want to come over here and we want to get Chrysler. Let's see, Chrysler. So we're there and we want to go ahead and read that. And this is where we lose a lot of data that might be helpful when we're working on a vehicle, is in mode 6. These are the last tests that have been run, and you can see how they're all 0. That's because the codes have been cleared. Now, what I'm interested in right here is I can see that cylinder 1 is my main misfires, and then I can see cylinder 4, and 4's got a couple of misfires here. So 1 has the majority of misfiring cylinders. So the code is for 1, and the mode 6 says it's for 1. Now, I never want to believe the scan tool totally. This is really important data that I want to take into account, but I always want to prove that 1 is my misfire. In order to do that, we're going to put a scope on this car and we're going to get some data. But first I want to go in and I want to just check the total fuel trims. So basically right here, we can see that short term is 0, long term is 10, so I'm about 10% on bank 1. On bank 2, I'm 10%, so these are still really close together. And 10% is not that much. So if I'm basically plus or minus 10%, I'm thinking that this is ignition or mechanical problems. If I had, let's say, 20%, I'm thinking I might have a fuel delivery issue at that time. So right now my first thoughts are, is this is ignition or mechanical? So really what I want to do now is I want to go ahead and get the scope on the car, and I want to verify what cylinder or cylinders are really misfiring on this car. So let's go ahead and get the scope on it. The battery is in the trunk in this car, so you need to come and we want to get right at the battery, and we want to be on the battery for proper voltage testing. In order to find which cylinder or cylinders are misfiring, I want to use a pressure probe that's going to go into the exhaust. So we're going to put this in the exhaust, and now that's going to read the pressure changes going in and out of the tailpipe, and by these pressure changes I can tell what cylinder or cylinders are misfiring. So I've got channel 1 connected to the tailpipe sensor. I've got channel 2 connected to the cylinder number 1 ignition coil. So let's go ahead and look at the data. So now I've opened up some software referred to as the Intelligent Engine Analyzer. So I want to show you this. So basically I went to configuration, I picked Chrysler, I picked the right V8 with the right firing order, and now it's automatically detecting that cylinder 1 is my misfire. If we come back over here, we can get that strip data, and we can pause that. I can get my zoom, and I can come in here, and what I want to do is I want to show you what we're looking at. So do you see how we've got this drop with a really fast rise and a drop with a really fast rise? So this is cylinder 1 here, to cylinder 1, and this is the missing cylinder, which is also indicated by 1, and that's being counted over here. So when I come over here, I can see that we're counting this up as a miss. Now I'm idling. Now they're telling me that once I'm under a load, they can't feel it miss. So let's just try to get some little throttle in here. We'll reset this, and we can see that we're firing the cylinder. It's clean now. So that's 2,000 RPM, and we're still pretty clean here. We're not having a misfire. I want to drop it down to about 15. So that's 15, and we're just starting to show maybe a misfire here. But when I go to idle, this is a dead miss, and it's on 1. So now what that's done for me is I've confirmed that cylinder 1 is the cylinder missing, and it appears right off idle that it's not misfiring. So this is an idle type misfire. So what I want to do now is I want to go ahead and I want to get the scope, and I want to get in all the coils, and I want to look at the ignition waveforms to try to figure out what's going on maybe with the ignition, so I can get a better diagnostic idea of what might be wrong with this engine. So let's go ahead and get those coils connected. I've connected the ignition coils, and I've connected channel 1 to cylinder 1, channel 2 to cylinder 2, and so forth. So now each channel represents the cylinder that it's connected to. So let's go get the data from these. Now that we have the ignition coils connected, I want to go ahead and we want to shut down the IEA, and I want to bring up the ignition software. Now we're going to need to unplug the tailpipe transducer as well. So I want to come over here really quick, and we want to just get some data. So they're all connected, so we're good there. So now we're going to come over here. Right here we're going to open up some ignition software. And so what this is going to do is I'm going to raise my trigger. So this is all of the cylinders overlaid with a single trigger. So now I can see what's happening in each one. So what I want to do is we want to lower this limit. Want to adjust it to where we got a little bit cleaner waveform here. So now I can really see what's going on. Now this is at idle. You really can't see a whole lot that would be occurring here. So what I want to do is I want to just raise the idle up just a little bit. Now right here, I can see the other cylinders having some turbulence in them, and that yellow one is flat. See how we have turbulence over here and the yellow one is just flat? See how we've got turbulence? They're popping up, but the yellow one doesn't. It has its turbulence over here. Somehow that's really different. definitely see how these other cylinders have more turbulent activity right off idle the way they should. And the yellow one just doesn't act like it's got any real turbulence. At idle it shouldn't, but as I come up off idle or I rev it, I'm gonna have turbulence like that where I revved it. Where I go to idle, these should be pretty smooth without having turbulence. As I raise it and I start letting more air into that cylinder, I should have more turbulence, but once again, I can see that that yellow one is just flat, but the other ones are not. So what I want to do now is I want to get out of here and I want to come over here. We want to just get some basic data here. I want to get my zoom window. I want to just look at this over here now. And these are our fires, and what we're looking for is just, we can already see that at idle they all look really, really similar. Now what I want to do is we want to go ahead and we want to give it a quick rev. And then we want to zoom in here. What I'm looking for is I'm trying to see what's going on with these cylinders. We know the yellow trace is the one I'm most worried about. It's the one that appears to be the misfire. Right here, the green one probably looks like it might be lean. You can see how it's coming up really quick. Purple's a little bit lean. The yellow doesn't look that bad. I don't really see much wrong with it, but we know off idle apparently it's not missing the same way. Here we can see where this doesn't look like I had much air entering that cylinder somehow. Here we're okay, so we'd want to see that repetitious before we would think anything of that. See, the rest of these are a little bit bigger, but nothing obvious. And again, we've got something going on that's different right here. Okay, so right away, I can see that I have something going on with one. I really don't see exactly, but the turbulent activity definitely is a flat line, and it should have turbulence as I open that throttle up a little bit. You can see all the other cylinders have turbulence, but number one does not. I don't really see it being lean or anything, but one thing I want to do real quick is I want to move half of the leads of the engine over to the injectors, and I want to get into the injectors, and I want to make sure all the injectors are firing and they all look equal. So let's go ahead and move those leads. So now we're in the injectors. Let's go make sure all the injectors look okay. We have the injectors. Let's go ahead and look at those. Now to do that, I want to come over here. And so we want to turn off the coils. And right away I can see that there's a difference on that red one is on one. And it's a different injector, and that waveform might be a little different, but let's go ahead and open this up because I've got the voltage way smaller now. So So here they are, and I can see what I was mainly interested in is looking at the on-time differences. This is a single trigger, and do you see how they're all staying really close? The on-times aren't moving that much. Now I can see that there's a difference on 1. So what I want to do is I can see that all of them are on the same amount of time, and that was mainly what I wanted to do. Now I want to come back over here and I want to get a trigger, but I want to trigger on 2 right here. That's the injector. I want to increase the time where I can see this. Open that up. So I've got plenty of current. You can see that the tower is very wide. The clipping diode, or the zener, is up here. We can see that we're on and everything looks right, but this tower is a little bit different than the other tower. So what we want to do now is we want to trigger on 4, and we can see that the bump is different on this injector right here. Now again, I'm not sure. I don't think that that's anything. I think that that's because they've had a bunch of different injectors in here. When I connected, the injectors all look new, but it looks like the injector on number 1 is even different than the other ones, like someone's replaced it again. So I'm really not sure. But we definitely have something different right here. So I think that this is just a different injector, but what we're going to go ahead and do is I'm going to go ahead and flow test these injectors just really quick to make sure all the injectors have the same flow rate. So let's go ahead and get that test set up, and then let's go ahead and flow test these. So I've set up this test. I've got my pressure gauge connected into the rail. I've got the relay out so I can charge my rail. So now I can go ahead and charge it, and I've bypassed from the battery directly to the fuel injector because these have ASD relays, automatic shutdown relays. So I'm not going to power this if I'm not cranking, so I'm just bridging it. Now I'm going to go ahead and we're going to take this lead out and we're going to put this in. This goes to the scope. So now the current is going to go through the scope to ground, and it's going to pull this down to ground, and I'm powering it on one side and I'm grounding it on the other. So now is what we want to do is go ahead and start this. Okay, so we can see that basically our drop, we clearly see the drop now. Now is what I want to do is I want to go ahead and we want to charge the next one up. And then we want to move this over. We want to just get in this one, and we want to go ahead, we want to drop that injector. Now what I want to do is I want to charge the rail, and we want to come back and we want to go ahead and get the next injector. Go ahead and drop that. I'm going to go ahead and charge it up. I'm going to go ahead and get the next injector. So now we can see that these injectors all flow about the same. So there's not going to be enough delivery difference between those pressures to create a misfire on one. The waveform's a little different, but that injector, somebody's just changed it again. So it's got a different pintle bump in it, but the injector delivery is the same. So the injectors are okay. In the coil, we know it's firing because we have turbulent activity, and that spark is going across the spark plug electrodes. So now is what I want to do is I want to take the spark plugs out and get into the cylinder and do an in-cylinder compression test to try to figure out why this vehicle has a misfire on one. So let's go ahead and get that connected. tailpipe pressure transducer to channel 1. I've connected channel 2 to the ignition coil, and I've terminated the 2 coils so we're not going to get any arcing. Channel 3 is connected to the 300-pound pressure transducer, and channel 4 is connected to a -30 pressure transducer to the intake. So the first thing that I want to do is I want to do a cranking test on this. So I'm going to go ahead and I'm going to unplug all the coils. Okay, so let's go ahead and set the scope up for the pressure transducers that I've installed on this engine. So the first thing I want to do is I want to go ahead and we just want to go to 4 traces. It's going to make it a little easier. We want the 25 inches of water for the tailpipe, 500 for channel 2, that's ignition. Channel 3 is going to be the 300-pound pressure transducer, that's in cylinder. And channel 4 is going to be the manifold vacuum. So now we want to just come down and we want to go ahead and zero these. We want to come over to the measure and deep record screen. We want to go ahead and start this. And now we're going to give it a crank. I want to go ahead and stop it. Okay, so we can see where we have the throttle plate partially closed and we're pulling down and then it opens it as we're starting it. We want to go ahead and we want to go into the zoom window. We want to get these 2 down here just to start with to take a look at. We can see that the ignition is happening close to target. So we can see that if we came in here, we can get the cursor. It's firing right at about top dead center, and this one's going to fire right about top dead center. What I want to go ahead and I want to do now, let's go ahead. I want to go ahead and mark this, so we're going to mark the cam so we can see that this is the cam. Now we can see that the 2 towers look pretty even. And we don't have a lot of pressure here, but we did get up to about 160. We'll look at that here in just a second. I want to go ahead, so right here we can see we're about 160. And a lot of these, they're a little higher than this, but that would still fire the fuel, I would think. We'll get a look at that. What I want to do right now is I want to come in here and I want to look at where that cam is. So I'm going to go ahead and we're going to smooth the data. That'll just help me clean it up a little. Now the exhaust pocket, we're going to go ahead and we're going to come in here and we're going to... The exhaust pocket right here is a little bit earlier than I'm used to seeing these. So it's not far enough off to where it's going to be a real problem. But it is off a little. So if I get the cursors, we're going to go ahead and remark this. And then I'm going to go ahead and I'm going to get the cursor. And what I want to do is I want to measure from this line here. And we want to measure to the bottom pocket. And basically, I'm a little before the 60, and that's okay. The other thing that I can see that's a little different is right here, this amount of distance, that this is a little higher than what I'm used to seeing, but not that much. And that comes from having the cam timing advanced. And on these 5.7s, they are advanced. Now this is 2.3, and that's too much. So basically the most I want right here, the difference is less than 2, and really these should be a 1 to 1.5. This is a lot. And if the cam timing opens early, sometimes I'll have this higher. That's usually what causes it, or a leak can cause that. The other thing that we can do is we want to come over here and we want to see basically what this is going to be, and we can see that this is right before the 30 degrees. This is 30, 60, 90. We can see 36 degrees, and that's about right for these cams. And we can see that this marker here is falling the edge. This is where the valve opened, and it fell down and it crossed about halfway down the ramp at the 360 point. So that's top dead center here. And that's one crank revolution. This is the second crank revolution, and I can see that I opened this guy a little early. So what I want to do now is I want to come out and I want to look at this intake pull up here. So let's go ahead and turn this off. And right away, I can see that I've got a drop happening in that pull. Do you see that drop? Okay, so let's go ahead and get the cursors and let's bring these over here. And we're going to mark these from here to here, roughly. And this, I'm not exactly accurate because I'm not right through the top, but I'm close enough. So now is what I want to do is we want to go ahead and mark this out. So I want to change the firing order here. This is an 8-cylinder, 1843. So I got my firing order. We're going to mark intake, and now we're going to return. And we can see that this is 1 and 1 is dropping here. Let me go ahead and we're going to zoom in on this more. I'm going to make this a little bit bigger. We'll go ahead and remark it so our markers are here. Now do you see how this is a pull? In other words, the valve opened right here and the valve drops and then the cylinder pulled. The valve opened and it came down and then it pulled up and then it drops. Now 1 has a pull because I have a difference here from where I dropped to where I went up. But I had a much bigger drop here. Notice how the drops on these others are very small, and this one is losing way more vacuum. So what I want to do is I want to move this over, this gridding. So you can see that I'm marking this right through where the peaks are, where I open the valve. I opened the valve right there and it dropped. I opened the valve and it dropped. Do you see how this one opened before that marker? Do you see how this one and this one is actually a little behind? These are the top dead center marks basically, guys. This valve opened right on that mark and fell. This opened earlier than that and fell. This valve looks like it's opening earlier to me than these other cylinders are. And if it opened early, it would have a bigger drop. Now that would be something to do with the camshaft is what would open that early and make that drop. That's different. But that's definitely opening earlier, and I've definitely got more drop, but this cylinder had an intake pull, and the pull, the delta T, or the difference here, is, wow, it's different. They all pulled, but this guy has way more drop. And you can see that I'm building vacuum, and then it drops, and then I built vacuum, and then if we come across here, we'll see that it drops. Well, this is a problem. I have something wrong here. So now what I want to do is I want to go back up, and I want to come over here, and I want to look at over here, and I want to just see. So the tops, if I'm looking for high, low, highs, these are all really even. That just doesn't look like a valve is leaking there. Yeah, but we can clearly see that we got a drop in here. I mean, clearly it's repetitious. So now is what I want to do is I want to go ahead and I want to put the coils on here, and I want to fire the engine up, and I want to see it running. The valve timing is really close for these 5.7s. This might be a little further ahead, but it's really close, and I don't think that would cause it. We'll want to check another cylinder too to just see what the other cylinder is. But I've got a problem on one. Let's get it running and let's see what we can see. Now we're ready to go ahead and start this so we can get a running engine. So we're going to start the data here. Okay, so we got it running. Want to give it a quick rev. Always watch to how fast it recovers and if it recovers to the same level or not. That's really going to be important. A lot of times if you rev one, you'll actually create a problem. So now that we've got this, we got it running. So we want to get our zoom window, and I want to come in over here. What I'm interested in is we're interested in looking at this waveform. Now I look like I have a pretty good pocket here. I see definition. It comes across. Looks okay, so let's go ahead and let's mark it. So I can see that the valve pocket is right about at 60, and it rises in the bottom dead center mark. The rise is in front of it, and that's about normal on these. This is dropping before that period and dropping down and coming across. And we can see we're coming over roughly at 45 or so degrees after bottom dead center, and it rises. The cam looks pretty close to what I would expect to see. Here, if we come in here, we can just check to see and make sure if the cat is got a problem, and this looks okay. What I'm really interested in is where we come down, and this is starting to decel. And what I'm looking for is this front pocket to break down. Like if I had a problem with a valve seating or a leak, lots of times I'll get some breakdown here. So we could come in and we can zoom in on this to where we can see it better. I would see this front edge warping and flat bottoms, cuts from the front or the back. Those are all indications that I would have some type of a problem there. Also, make sure that this peak is higher than the exhaust plateau. If it's really close or equal, there's a problem. It's not letting air into the engine. So this all looks okay. The pockets are really well formed. You always want to check this in a couple of different places for the cam timing. Again, we're a little before 60 on the pocket. That's where I would expect this to be. We're dropping maybe a little earlier on that intake. This seems early. Comes down and it comes across, and again, the bottom drop is maybe even a little late, but this is close to what I would expect. Let's go ahead and get some data with it running here and just take a look. Let's look at that intake pull. Okay, so that's interesting. Look at that. I can see that intake problem repetitiously. That's repetitious right there. Do you see that? That drop is happening every time, and that's the same drop we saw when it's cranking. And that's a drop that's happening from this cylinder, and this is cylinder 1, and that's a drop. Okay, so what I want to do now, so I want to come down and I want to look at these pockets for any kind of breakdown. What I'm looking for is this front pocket to be warping, mainly warping, cuts, flat bottoms, and these look okay. And we can also do a clean. It'll clean it up. It'll make it easier for me to see what I'm looking for. Very little, they're really clean, but the heads have been replaced, so I would expect that they would be okay. I don't see a problem there, is what I see. It almost seems, the other thing I see, let's just look at something else here. We saw that the difference here was more than what I would be expecting. So 1.4, that's a little bit better than like what we saw before where it's cranking. And remember when we looked at that when it was cranking, it had a lot of vacuum on it. And normally cars don't have that kind of vacuum, and you really can't look at that difference in pocket. But on this vehicle, these turn pretty quick and the plate's closed, and we get some pretty good vacuum pulls during crank, which normally we're not going to get. This seems to be good. The cam timing seems to be good. This is just a little bit higher. I don't really see a problem with it. The only thing I can really see that's just right away, all the high-low highs, I don't see any of those, but I can see a drop repetitiously in that vacuum pull. That's just clear that that's got a drop. See the drop, see the drop, see the drop, see the drop. See how it's pulling up? It pulls up and drops, pulls up and drops. And that's something dropping the vacuum on the cylinder that's missing. What I want to do now is I want to go ahead and I want to put this cylinder back together, and I want to get in cylinder 3 right next to it, just so I have some comparison. So let's go ahead and do that and take a look at that data. Now we've moved the pressure transducer to cylinder 3. Let's go ahead and get that data. So basically what we want to do is we want to go ahead and just start it, and then we're going to do a long crank. Okay, so right away we have really similar to the same pressure. So what we want to do is we want to go ahead and we're going to get the zoom window. We're going to come down here and take a look at this cylinder to just see what we've got. Right away you can see that this difference right here in the pocket is very different from the other one. They're way more even. So what I want to do right now is I want to just go ahead and mark these. Towers are even, and this is a good cylinder, so we shouldn't be having a problem with this, right? We're going to raise this up. I want to just come down in here and I want to look right through here. See how close these are? So if I go ahead and I get those cursors and we bring the cursors down, we were over 2 psi difference on the other one, and that's higher. And remember, cranking, we don't normally get this kind of a vacuum, but on these Dodges we do. Do you see how we're 138 difference? So it's a pound difference between the intake pull and the exhaust, and usually that shows either a leak or an early opening of the valve or more cam timing difference between these two pockets. We can also see that our pocket right here, let's go ahead and clean these up. We're going to smooth them. Our pocket is about the same place over here. It's right at about the 30. And our line right here is falling. The other one, that line fell through the middle, and this was a little further over. So the falling ramp was a little further to the right, a little more retarded, but the opening looks very close. And then this guy is real similar on the exhaust, so that's bottom dead center. That's 3060, and we're really close there. Let's go ahead and we'll see exactly what that is there, where the pocket for the exhaust. So basically we're about 75 degrees, and that probably needs to be moved over just a hair. So about 72 degrees. Again, these pockets, this is a little bit different, but the pockets are very different. This ramp halfway down was crossing, but that's just a few degrees different. This is really close. I don't see a lot, but I can see that drop now is moved. So let's go ahead and come up here and we'll see it move because we're in cylinder 3 now. This is cylinder 1 that's having the problem. This is cylinder 3. We can go ahead and mark this again for the intake. So I moved those markers and you're going to have to put those back. So let's try that again. And we also have to tell it we're in another cylinder. Now we can see that this is 1 over here where we're dropping, and this is 3, and it all looks okay. So what I want to do now is I want to go ahead and I want to put the coils back on, and I want to get the engine to start, and let's see what we've got. I've got the coils connected, so let's go ahead and start this up. Go ahead and get the data going. Again, we want to watch the recovery time and we want to make sure it comes up to the same level. So we want to get the zoom window, we want to come in here. Want to go ahead and mark this. What I'm interested in is down here. We can see that that's about 60, so we're good. The pocket is opening right at the top dead center mark. The other one's opening a little bit sooner than this. That's a little bit later, and we have our fall, and then we come across and we rise. So what I want to do here is I want to just get this down, we'll remark that, and we'll have better marking. So this is right about the same place, we're about 60. This comes down to about 30. Our ramp is falling roughly a little bit, just this is a little bit later, and we can see that the mark is closer to the top dead center point. Again, and we can see that these two are more, we're going to see this, that where we don't have as much difference between the pockets. So if I basically go to the pocket and go through the median right here, we're going to see that we have way less. So these pockets are different. Normally, again, what happens with the pockets is if the valve opening times are different, this pocket will be higher. You always want this pocket within 2 psi of this. And if this pocket is any lower idling, if this pocket's any lower than this, it's leaking. In cranking, that pocket should normally be lower than this by about 2 psi. If it's more than 3 psi lower during cranking, then that would be indication of leakage, which I didn't see. So we can come back up here and we can see that we don't really have any high-low highs here, but again, we're dealing with a good cylinder. We can come down and we can see that it's good. Let's go ahead and get some more data here. Let's go ahead and do one more spot to just check the cam timing. You always want to do multiple points because these are pressure, and since we're dealing with pressure, we always want to look at them several times. So here we've got this guy opening about 60 and he's coming up, and the ramp is right before top dead center, about the same as the other. Real nice round pockets. Notice they look like skateboard ramps. If they start to warp or this pocket's breaking down, it's indicative that you got a valve leaking. Obviously this is a good cylinder and we're not having a problem. This is atmosphere. We pulled down right at top dead center, fell, came across, and we started to rise right at the 30. On these 5.7s, the cam is always to the left. This ramp is a little advanced, this is a little advanced, and that's pretty normal. Same over here, we're opening or closing the intake valve at about 30. Usually that happens at about 60, but this is normal for these cams. So we can sort of see the difference here. Again, we can come up and we can get some data. We'll give it a real quick rev. And then we're going to be able to come in and we're going to be able to see what kind of pressure we got. And again, we can see that the exhaust isn't plugged. If the exhaust was plugged, we'd have a ramp right here, like it would look like the intake, and it doesn't. We're increasing our pressure enough for a quick, easy rev from where it is idling. Again, where it is idling, we're roughly about 55, 60, so we're good. No high, low highs. So basically, is what I can see is the cam is very similar in the timing structure as the other one. The intake valve on the cam on the cylinder 1 is opening earlier. And I think that earlier opening is the problem. Now, they've already put a cam and lifters chain. That was the first shop. The second shop put heads on this car. The third shop did the rings and re-rung it. The four shops changed coils, injectors, all kinds of stuff. I don't even know. That's all hearsay. You know, none of that really matters. Don't ever let what someone said they did make a difference in your diagnostic strategy, because did they do it, or even did they do it right? I really don't know. But what we're going to do is I'm going to get the shop to take the valve cover. First, they're going to have to get authorization, but they're going to need to be able to take the valve cover off and possibly get the head off to where we can look at that cam and see what's up with the cam. But I'm pretty positive this problem is in that cam lobe for the number 1 cylinder. We have a problem there, and we can see it in the cranking compression and the running compression. This is a mechanical problem on this engine. So we're going to give this back to the shop, and they'll go ahead and they'll get this thing torn down, and then we'll come back and look at it. And if they don't get authorization, well, then it's going to be hard to get back over here to look at it. But we've seen how to go about doing this diagnostics to find a problem like this, because this is a really hard problem. And this is a really hard car. This car has been to a lot of shops. It's had more parts than most cars I've ever worked on. So now that we know what we're doing, we're going to give it back to the shop, and hopefully we get a chance to come back and take a look at this when they get it torn down. Okay, so we're at the shop, and the shop got authorization for the teardown on this motor to try to figure out what was wrong with the missing on number 1. Let me show you what's going on. So they've pulled the heads off of this, and we can see that the DOD system, and this is going to operate 1 and 7, and these operate 4 and 6, and that's the ones that go in displacement on demand. They refer to this as MDS for Dodge Chrysler products. Now, what's really interesting is the number 1 cylinder has the wrong lifter set in it. If we look right here, it says conventional. Well, this is for a conventional cam set, not a DOD. Now, all the other sets are correct. So this one is for 7. Do you see these big holes right here for the oil? This is for DOD, and do you see right here where it has MDS? Well, this is for a DOD system, and this lifter rack was correct on the 7, and the other ones over here, they also are correct, and they have the right ones for 4 and 6. But for number 1, the cylinder we're having a misfire has the wrong lifters for the cam in this engine. That's what's causing this misfire. So really a great problem. What you got to take away from this is we diagnosed this vehicle and the data clearly showed that this was some type of a cam lifter problem. Once we get it down, we can quite easily see what it is, but before you tear it down, you got to know, you've got to have the right tooling, and you got to trust those tools. You got to trust the data. Always follow the data. Set up an event-driven diagnostic plan where one test is driving the next test. As you can see, the plan I laid out for you clearly showed that one had a cam problem with how it was opening the valves. Now we can see that the lifter arrangement for this DOD car is not the right one for the cam. So these guys will get these put back in, and this car will be ready to deliver back to the customer. And you know, the customer is going to be happy. They've been trying to fix this car for over a year. You just set yourself up with quality tools, follow a logical process, and you too will have good troubleshooting in your base.